Welcome to the webinar. I'm Rick Levine from the Network Association of Uniform Manufacturers and Distributors, NAUMD. We are an international organization that of a few hundred companies that share resources, help build our resilient supply chains, and provide network access to each other to obviously do business, but also to help all ships rise through growing together. So we provide news. You can opt in at naumd.com. There's data in our news sources that we publish. We offer network access in our member portal, the uniformnetwork.com, which is open to members. And once a year, we have an in-person event. Next year, it is in Daytona Beach, Florida, May 5th to 7th. So we encourage all of you to visit us there. Thrilled today to have Jan Berenger with us from Hohenstein, Dr. Berenger, sorry, and scientist extraordinaire who is going to talk to us today about mesh size impacts, 3D design, the technology of it all. And I'm very curious as a geek myself to learn the latest on what's going on there. And so I've probably already even said too much, Jan, so I think I'm just going to turn it over to you.
Yeah, thanks a lot, Rick, for the introduction, and also thanks again for the opportunity again. I think we are kind of a repeating guest with your organization. So also welcome from my side. Good morning, good afternoon, good evening, wherever you are on that planet. It's my almost evening, so it's around 5 p.m. In Germany today, or right now. And so stop the talking and start sharing. So sharing my screen, give me a second. Going to the topic, how the mesh size impacts realistic 3D uniform design. So it's going to be a little bit technical presentation today about 3D simulation, how to play with the mesh size and basically find the sweet spot between the mesh size and your actual virtualization of the garment. Quick intro, why digitize? I think most of you who are attending, maybe they have tried already a 3D garment design in the digital world. And basically 3D is an opportunity and a facilitator. So for example, if you look, the garment industry is the second largest polluter on the planet. So we have to become sustainable. This is very important. And currently about a third of all manufactured garments are not sold and ends up basically in landfill. So also, if you, for example, look at women's, so more than 50% of women, they actually don't find the right garment. So in terms of body size, fit, and so on. And 70% of women and men, they actually don't fit into standard sizing systems. So it's really required that it's a little bit more improvement in terms of 3D garment design and sizes and fit. And of course, if more than 50% of women don't fit in their actual garments, or they don't find garments they actually like, it's a huge market opportunity. It's a 50% market opportunity of women's market. So, and of course, in terms of 33% being discarded on the landfill, it's also an option for an opportunity for sustainability. The applications for 3D simulation, we have to separate a little bit. We have on the one side the visualization, on the other side 3D fitting. So what most companies do is currently the visualization. It's basically creating your design prototype, your garment prototype in a digital form, and you use this for digitized product communication for the designers, for your sales team, and for the marketing, for your web shops, for example. So just basically make a very nice three-dimensional image of the garment, which should be as close as possible to the real garment. The other part would be 3D fitting. This is the more advanced level in 3D design, where you actually virtually fit your digital garment on a digital avatar. And of course, this is done to reduce the fitting prototypes. And Usually you start with the visualization. If you're experienced in visualization, you can go for the next step for the 3D fitting. So 3D fitting is a little bit for the pros at the moment. Visualization is, according to the systems, the software systems that is out there now, pretty easy and straightforward. Yeah, so why digital prototyping? Well, reduce physical prototypes with 3D simulation, no longer make samples, ship them around the globe for certain fittings, enables fast and clear decisions, improves process time and efficiency, reduce the cost in shipping resources, reduces your carbon footprint. So this actually fits in very nicely to your sustainability story of your brand. And when we look at uniform sales, basically a digital twin, digital size advice, virtual fit, reducing returns, improve over user experience. And this also improves the, let's say, dressing experience of uniform customers, which digital is always cool. And of course, everybody can exactly see how the garment will later on look like, because usually the old-fashioned paper catalogs, they might look nice, but if you can simulate the garment in a very realistic environment, this looks actually nicer. Yeah, and of course, the sales team can use the digital garments for their sales pitches in virtual showrooms for the sales samples. So a large variety is possible, color change is possible very quickly, so it's very versatile. And of course, what is currently mostly used to establish a clear communication along your supply chain. And this is the planning, the communications for tech packs. This is very helpful if there's a digital version of the garment included in the tech pack. And of course, you can do the pre-testing of your pattern of your garment in multiple sizes and just check in the digital way if the garment is looking nice and also meeting the requirements of your target group, for example. So basically the digital transformation and sustainability, they go hand in hand. So this is what we just highlighted on reducing physical prototypes, reducing returns by a more customized design and a faster design, and overall reducing your carbon footprint. Yeah, that was the intro. Now getting into the topic, 3D simulation and mesh size. So what is the connection between those two topics? Well, for those of you who might be a little bit experienced in 3D garment design, we have actually 9 factors that impact the realistic appearance of a garment simulation. Of course, the avatar is very important. Today, we will focus on the mesh geometry and on the mesh size. So we actually have 2 factors in the mesh. It's the geometry and the sizes of the mesh. Pattern is important. The material, the fabric is important. So how to digitize your material, light, viewing angle, camera, of course, the person who is sitting in front of the computer, which is the user, the software, of course, and the hardware has an impact. So today, only focusing on the mesh part. Well, this is one too much. As you can see, meshes are defined by a geometric pattern. It could be triangles, it could be rectangles, and of course by the size of those shapes. Here in this case, it's triangles, large triangles, medium triangles, and smaller triangles. The requirement is, of course, for your precise garment simulation that your material parameters are suitable for your real fabric, and therefore it's required that your physical fabric is digitized. There are 2 ways of doing this. You can do this with the software kits from the software providers. I've listed 3 of them here. The challenges basically is, of course, the testing device for Clo, for example, only produces data for the Clo software, which is of course by intention, and the other ones also. So currently there is no standardization behind it. So if you're using the one system, you cannot use it for the other system because it will generate different data. And of course, the fabric needs to be physically available. You need to have a fabric swatch that you put into a device, then it's kind of processing the fabric, bending, stretching, and whatever, and then some digital parameters are generated that you can directly import into your software system. The other option is independent lab testing. So Hohenstein, for example, is one of the providers. Of course, also the fabric needs to be available as in a physical form, about 1 square yards. This is what we required. There are fabric specific tests. The data is converted for various software systems. So this is a more versatile approach. You can use independent lab testing basically for different software systems, not only for one. And again, also there are no standards yet. So ISO, it's a little bit starting right now, but not really taking up speed. Advantage is reproducible results for all software systems. So you are not bound to one single software system, and it enables, of course, also real digital fitting. In terms of material parameters, let's look at a woven fabric. So a little comparison between two different providers and what we, for example, offer. And you can see the reality, which is the photo always on the left side. And you see we are pretty close to the realistic appearance. Two other providers, they're a little bit further away for this woven fabric. If you look at another fabric, an elastic fabric, again, the comparison between the realistic appearance, so the real photo of the fabric, and the three different digitization providers, we can also see that we are a little bit closer to the reality than the two other ones. Looking right from above to the drape picture of the garment. The reality is, of course, the most close one to the reality. We are a little bit closer again, and the two providers, they are a little bit off. So you see, it all depends how precise the digital parameters are to come to a realistic 3D simulation. So material parameters is one key. And then, of course, we're starting then with the next part, which is the mesh. Why it is important to look at the mesh? Well, simulation accuracy, product visualization, time savings, and performance optimization. So time savings and performance, they basically go together. If you, of course, increase the mesh size, so make the meshes smaller, it increases the computing time of your hardware. So basically, you have to find a sweet spot, and this is what we were investigating in one of our projects. Yeah, mesh resolution, the definition. Well, the plane consists of triangle or rectangles. This is what we just learned in one of the previous slides. The mesh consists of particle and links. So the finer the mesh, the more detailed the projection or the simulation. And by user guidelines, we have certain definitions, definition by degree of simulation and attention to detail. Each software has its own definition. So you cannot use the one parameters from one software system in terms of the mesh size for another software system. So you always have to be or get acquainted with your individual software system. And of course, it's important to align with the suppliers. So for example, if your suppliers uses your 3D data in your tech pack, but has a different mesh size setting in the software they use, the appearance will be totally different. So therefore, it's important to align along the supply chain, basically be consistent. I talked about the mesh size and the conflict with the computing time. It's basically the vertices versus the particle distance. And as you can see, the number of vertices, so basically the number of triangles, for example, and the particle distance. The smaller you make the particle distance, of course, the finer gets the mesh. And this basically means an increase in those vertices. So for example, if you go from 3 millimeters to 2 millimeters, it's already a doubling, almost a doubling of the vertices. And if you go another 100% smaller from 2 to 1 millimeter, it's basically it's skyrocketing. So the more vertices you got, the higher is the computing time and the more time it takes to do the simulation of the garment in the software. So when we look at the impact accuracy of the fabric simulation, so we have identical material parameters. So it's the same fabric, the same set of digital parameters, and you just play around with the particle distance. On the left side, we have 3 millimeters. On the right side, we have 50 millimeters. And you see immediately a change in appearance of this draping image here. Of course, it's a little bit exaggerated. 50 millimeters is quite a large particle distance. Nobody would actually use that. And 3 millimeters might also be a little bit too small. But you can see the particle distance has a huge impact on the drape of the fabric and on the appearance of the fabric itself. So the challenge, mentioned it already, you have to find the sweet spot between the resolution of the mesh and the simulation time. So basically, the coarser the mesh, the less accurate is the simulation, but the faster you can do the whole processing and the simulation. And the finer the mesh, the higher the computing effort of the simulation, and the longer it takes to basically simulate the garment on an avatar. So finding the sweet spot and let's say getting some information a little bit earlier in front, you have the information later in the summary. It depends on the application that you actually use 3D simulation for. Or is it just design approval? You can do it a little bit faster. If you're really going into details for web shops, for example, you have to increase the mesh size, but I will come to that later on. Yeah, the mesh. So what we did in the project, we created a test design. We had this acrylic tube, and we placed fabrics in real world over the tube, and we basically did exact same in the 3D world as a simulation. So we had 3D, we had 3 different fabrics in 3 different simulation software and simulated those 3 fabrics, a lot of 3s in there, with 3 different mesh sizes. So basically comparing the simulation versus the reality. So we also checked different workmanship variants, like a dividing seam, a fold, and a gathering. And this is the real picture from the physical sample. And then, of course, we did the same in the simulation software. You see for the seam construction in Clo 3D, NVIDIA, and vStitcher, these are the 3 software systems we actually used in the comparison. By the way, I will not answer the question later on which one is the best software system and which produce the best results. Basically, all are equal to each other. They work differently, and it depends on your other software environment, which system fits best in your existing software environment, and also which your user basically prefers. So this question I'm not answering because there is no answer. Yeah, going into the mesh resolution. So simulation with 2 different mesh sizes, particle distance 15 millimeters and 7.5 millimeters. So the particle distance is the average distance between the vertices in millimeter. And you can see there's a clear impact in the appearance if you basically halve the particle size from 15 to 7.5 millimeters. This is then displayed in the mesh resolution. You can see the 15 millimeters rectangles and the 7.5 millimeter rectangles. So starting with the examples, with the demonstration, the sample with the fold. Well, we did over 30 simulations, so this is just a small excerpt. I don't want to bore you with more than 30 simulations. So looking at Clo 3D with triangles, particle distance 15, 7.5, and the photo. So this is always what the sample actually in the simulation should look like. This is the real picture of the physical sample. And you see, of course, with a smaller particle distance 7.5, from our point, it's totally sufficient to be quite close to the real world sample. When we look at VIDIA, so VIDIA has a different unit and a different setting in terms of particle size and particle distance. So this is converted for better comparability. So we have converted the parameters from VIDIA into particle distance. And again, 15, 7.5, and the real photo, you see 7.5 is of course closer to the real world appearance. When we look at the sample with fold, again, going back to Clo 3D with particle distance 15, 7.5, and the photo, 15 is definitely too high, 7.5 looks like to be a sweet spot, so it's pretty close at the real physical appearance of the fabric. Same for VIDIA, 7.5, again, is a good comparison or is a good match between the real sample and the simulation. Again, we have converted the units from VIDIA for better comparison. So what we also did, and this is what I mentioned before, depending on the application for 3D simulation, in which stage of the simulation you currently are, there might be some room for playing a little bit with the particle distance and of course with the speed of the simulation. So we asked 7 experts. The question was basically, for which kind of application would you use this simulation quality? And this basically goes back to the mesh size. So for which application in your daily work, which mesh size is basically sufficient or which is over-engineered. So we had answers in 5 predefined categories, which is the application, the product presentation, the draping behavior, design check, a quick pattern check, and basically no preference, so just no application. Yeah, you see, the answers are a little bit different. So for the product presentation, there's a clear trend towards a particle distance of 7.5, and also for this section here around particle distance 15. For the draping behavior, it also tends more towards to the lower particle distance. For the design check, we have a little bit different spectrum here in the answers. And for the pattern check, this was expected. If you want to check the pattern, there's no need to increase the mesh size. So it doesn't have any benefit if you increase the mesh size for the pattern check. It's totally sufficient if you do the pattern check with a larger mesh size, which increases your speed in simulation and also your efficiency. So basically, the closer you get or the closer you want to simulate the garment towards the real world appearance, the finer the mesh size. So we did this with some examples. We had a predefined pattern, we had an avatar, and we used only one material. So, and the key drivers, the results in the impact by the user, the textures, and of course the rendering, the light, the camera, and the viewing angle. So we tried to keep everything constant, that there is a good comparability between the different simulation approaches. So we started with close 3D, particle distance 15 and 3. Of course, we picked in this experiment a more, let's say, complicated garment. So where the simulation is actually brought to a little bit to the performance maximum. Of course, a standard uniform jacket is much easier to simulate than a more complicated base layer here, for example. So this special shirt here, and you see, especially when you look at this part here, the particle distance of 3 is definitely required to have a better appearance of the product itself. Particle distance 15 is too much. So this is not close to reality. When we look at V-Stitcher, you see the difference even more clearly. Particle distance 1.5, well, quite okay, but 0.3, I think this is a perfect setting for this one here. This almost looks like a real fabric and a real product. When we look into VIDIA, a particle distance 15 to 25, as you see, the particle distance are different from each software. 50 is too much, 25 goes into the right direction. You see there's a clear impact, especially in the upper part here of the simulation, of course, all the folds in the garment. So comparing this to reality, to the photos, so we took the same fabric, of course, took the same pattern and cut and sew the garment. You see, this is how the garment would actually look like in real world if we would place it on an avatar. So now we are comparing the reality, the photo, with the simulation, starting with close 3D and particle distance 3. And as you can see, there's still room for a little bit improvement. So the real world picture is much more detailed in that part, and that part of detail is not really achievable right now with the particle distance of 3 in that simulation. If we go to V-Stitcher, you see there's a little bit improvement with the grid 0.3, so a very fine grid in that software. You see that especially the folds in that area, they look pretty comparable to the real sample. But what you also might notice, especially here in the shoulder part, the simulation looks totally different compared to the real world. So this might be a little bit too much in that case, because on the one side we have a good match to reality, but on the other side we have no match to reality at all. And again, this is something that needs to be kind of tweaked out. So going with another particle distance like 25 with Vidya, you see this is quite okay. This could be a little bit more resolution here in that part, but the other part of the garment actually look pretty much like the reality, like the photo. So we tried to put everything together in the table. No worries, I won't read every single cell of that table, but we tried to categorize everything, what we found out. So for the pattern check, we had two categories like standard and detailed. For the design check, the same, draping behavior and product presentation. So it's always the standard category is for a quick simulation if everything works well in the garment, and the detailed can be usually considered if you want to present your simulation to your sales team or to other persons who are really interested in the physical or the almost physical appearance of the garment. So for Glow 3D, we have found out these requirements. Standard triangles, rectangles can be optional in Glow. And for the particle distance, 15 to 7.5, 7.5, 3 and 3. Same here for the rectangles. For V-Stitcher, there's only an option for triangles. So the unit is the grid in V-Stitcher. You can see for the standard 1.5 and the more detailed sections, it's 0.3 or representatively 0.7. In Vidya, we only have rectangles, and Vidya uses grid resolutions. So for the more easy part for the simulation, 50, and for more detailed part, it should go up to 15 or even 18. So the smallest mesh size, for example, in Vidya is 25, and 18 is only selectable for the color pattern part. So you have to basically modify the pattern size with your garment. For Glow, rectangle mesh is recommended with Glow 3D for smaller pattern parts only. So if you use larger pattern parts, stick with triangles. If you go for smaller parts, you might change to rectangles. And of course, for detailed, which means the close-ups or complex elements like folds or gatherings, therefore the detailed settings are recommended. Yeah, summarizing the presentation, that we have some time for Q&A. So of course, the mesh setting depends on your software system. So we have shown 3 examples of 3 different software systems. This is what we found out in our project is quite suitable for those 3 systems. Of course, there are different systems or other systems on the market, and this has to be found out separately for these kind of systems. Of course, it is depending on the level of simulation, the savings in time, resources, and capacities. It depends where basically it's most urgent for the simulation. If you have enough time, you can choose a higher setting. If you have to do a lot of simulations in a short amount of time, you of course have to reduce the mesh settings. What is of course always important, the impact of the workmanship on fit cannot be simulated. So this can only be done at the ready-made garment, at the physical garment. Workmanship cannot be simulated. Yeah, time for Q&A. Looking forward to your questions. Thank you for your attention, and thank you for the opportunity today to present our work to you. My contact data, QR code, and yeah, if you want to learn more about Hohenstein Digital Fitting, we have a separate website. Q&A.
Wow. Okay, that was a lot of information really quickly, Jan. So if people have questions, there's a chat tool, there's a QA tool. So feel free to ask anything, really. It doesn't even have to be about things you heard. But I mean, so I'm not as knowledgeable on the 3D tools, Jan, but it seemed to me that if you have the computer capacity, wouldn't you just want to use the highest, the best resolution possible every time? Like, or does it start to actually work the other direction? If you're working with something that's too fine, am I misreading what you're saying, that sometimes you can set it too fine and then you're actually not getting better results because you've set it too fine?
Exactly. So I would first answer with the last point that you mentioned. Of course, you can always make things worse. And this is exactly the case if you do the resolution too fine, you get artifacts. And of course, also the simulation time takes too long. So if your computer system is powerful enough, I think there is no real issue with computing time. But Rick, perfectly, as you mentioned, you're actually making it worse by increasing the particle size too much, or the particle distance.
So that's important to know, because you can't, if you're not seeing the results you're expecting or want, it's not just making it finer and waiting, which is what your research is indicating, at least as far as our technology works now. But the challenge for these software companies in their, kind of their AI world, is that as well, as how much of the information are they going to process, and or how much are they going to leave behind? So and going back up 10,000 feet, Hohenstein isn't offering software in the 3D world. You are helping to test variations and technology, trying to help us all achieve the best results possible with a variety of tools that are in the marketplace. Am I saying it back to you correctly?
Yes, 100% correct. So we are not selling any software systems. We basically help people embarking on that journey to digital. So this is what we currently do for a lot of our clients. Everybody would like to get digital, but what is very important, from what point are you starting? So what is your starting point? And we basically found out that most of the companies or most of the brands, they actually don't have any competence more in pattern making. So this is actually the very first thing that you need to do. If you want to get digital, you have to own your patterns again.
Yeah.
And if your supplier owns your pattern, you have a problem. So this is why we usually start with an analysis of the current state of our potential customer and say, okay, if you want to go digital, you need to first work on that and that. So you can see us as a kind of an independent technical consultant. So we don't want to sell anything. We just want to sell our services, of course, but we don't want to sell any products. And we also don't give, let's say, software training. So this is usually the job from the software companies. But what we do for our customers is train our customers how to best construct certain garments with specific software systems. So it's more the real world application, basically in your daily work time. So how can you be more effectively in constructing a shirt, for example? What are the obstacles when constructing pants, for example? So this is something that the software companies, of course, they do not teach, because of course they teach how to use their software, but we teach our customers how to best use the existing software systems to come to a simulation result as effective as possible.
Okay, but how do I, someone's asking, how do I get started, period, though? So right now we've just got, a person on staff who works in Adobe Illustrator, right? And draws silhouettes. And then we're relying, like you're saying, on our pattern maker or our our factory somewhere in the world to return, the specs of the pattern. And we're just trusting that our grader is going to magically solve the initial problems you said, which is, well, the standards don't really work for so many body types nowadays.
Exactly. And this is basically also not how it works. So it's not like you're buying a 3D system and then you can do everything immediately. So this is not how it works. So what is always required if you work with 3D, that you still have experience in traditional garment making. So as you mentioned before, you can make it worse when decreasing the particle distance too much, or increasing the mesh size. And when you have experience in garment making, you can say, okay, this doesn't look right. So there's basically something wrong here. And also the team that is working, or the person that is working, let's say from traditional 2D garment making to 3D garment making, the team needs to needs to be yeah, willing to embark on that journey. So that is the most important thing, that if you want to establish 3D in a company, the team really wants to do it. And if they want to stick to their old traditional way, it might be definitely a challenge.
So wouldn't starting with the materials that are included in the 3D tool that they do select and or can afford, wouldn't that be then a reasonable place to start? Or how important is it that we take the fabrics that we know we're going to be using and digitize those, which is the one of the conclusions of your research, which is it's better to do that.
Exactly. So all the software systems, they basically come with a library of predefined, let's say, standard fabrics. Of course, this library can be added more and more over time. We think for a starter, it's definitely perfect to work with the existing libraries. But as you know, especially from the design perspective, when you are a designer, you see a new fabric basically every day, and you want to have that fabric exactly in your garment that you are designing. And if the designer is not okay with the 3D simulation of the garment that he or she has designed, then you're lost basically. So this is why we say it's very important that, especially for design-oriented projects, the fabric needs to be as close as possible to the real fabric, and this actually requires that the physical fabric, so the swatch of the fabric, is digitized, so that the 3D simulation of the design garment is as close as possible to the real world prototype.
Oh, okay. All right. Two questions out there. I'm going to take the second one first because it kind of relates to what we were just talking about, Jan, which is, do any of the fabric mills, are they starting to offer like digital swatches, if you will, so that I can plug it into my, like Photoshop, for decades now, we've been able to add extensions and drop in patterns and other types of preset template things. Is the 3D world similar?
This would be the perfect world. So we know that some fabric mills are starting with that, let's say it that way. But I think for a designer, this would be the absolute dream if you can go on their website and just download the digital parameters and just start with a simulation before you actually purchase the fabric. So well, I think this might take a little bit longer, and of course, I have to be with the fabric mills there. It's also a cost factor.
Yeah.
So
sure.
the material digitization is, I wouldn't say a very expensive test, but it costs some money.
Yeah.
And depending on the amount of different fabric variations a huge or large fabric mills offer, it would be a really huge cost driver. But on the other side, we also think that fabric mills that are offering this kind of services, they have a huge business advantage at the moment, because they can offer already the digital file of the fabric. And of course, also those fabric manufacturers, they have to decide which files are they actually offering. Are they offering cloth files? Are they offering media files? Are they offering whatever software manufacturer files? And therefore, from our side, it's so important that we basically get aligned on a standard. So that is a kind of an individual format, so that at least the fabric mills, they only have to test for one format. And then this universal format can be provided and then imported in various software systems. But I think we are on the route to that, but that might take some more years if we have that finalized.
Agreed. And there's going to be a convergence with all of the imaging AI that's coming out, right? There's like, so that I'm thinking of that example you used for the seam across, the chest and all of the varieties of that. And, so we've got general AI that's doing that, anyway, that we're all experimenting with just for the fun of it. So so I see you've got the website up there for your own digital-fitting-lab.hohenstein.com, but someone else is asking also, like, where do you go to learn more about all of this? And are there, maybe we can't read at the scientific levels you're reading, but where are the places where we can kind of stay informed on a lot of this.
Yeah, as this technology is pretty new, for us, it was mainly learning by doing. Of course, the whole team behind, they are traditional garment makers. They are clothing technicians. So they learned the craftsmanship of garment making. But the whole 3D thing is basically new. And we know that universities and schools, they are starting to offer courses for a 3D garment simulation. So if you go to NC State, for example, I'm pretty sure they have different courses available where you learn the basics. But as this technology is pretty new, you basically pick one piece from one place and one piece from that place, and you put it together. So there is no, let's say, book that you can read where everything is in there right now, which teaches you everything about 3D garment simulation. So for this, the technology is too new.
I mean, I would imagine some of the suppliers have educational materials that, on their own websites, just as you're giving us a link to yours. If you're curious about info, I'm sure there's educational materials on all of the supplier sites also, but and there's always YouTube and TikTok, right? But
well, actually, a lot of the software suppliers, they have actually YouTube channels.
Yeah.
So where you can actually learn how to do the basics with their software.
Right.
We have YouTube channels out there from garment makers that just want to show what they are doing. So I think YouTube might be a good resource, but of course, every software manufacturer, they of course offer the basic training how to operate the software. But most of the skills for using this kind of software is acquired by the person itself in the everyday work when using the software. And sometimes this is also linked with frustration, and this is where usually we come in to limit the frustration with certain challenges in 3D garment design.
Yeah, I can appreciate that. Yeah. And I would imagine over time there'll be user groups as well, and so people can be, helping each other. But the community is probably still too dispersed to to find each other, right? But maybe there's another thing Hohenstein can start up: the 3D designer user groups.
Oh my.
Boy, I appreciate your time today and walking us through everything. Someone is pointing out 3D Tech Fest, actually, and I've attended that. That is a great event that each year does train, and showcases people, like you were saying, Jan, that are in the real world. I remember looking at a few of their talks that people were creating avatars and were, and it was very interesting. One was diversity and inclusion. I remember that one. I think that was a year or two ago. There was a theme of that, and so that's another topic of interest. So that's a good one. Thank you, Jill Coleman, for pointing that or reminding us that that's a good resource for everyone. So if there's no other questions, I will let everyone go officially, so you don't have to feel bad about dropping off. Again, Jan Berenger, you want to put your contact info back? If anyone has further questions, this is how you reach the good doctor. And I thank you all for your time.
Thank you. Have a nice day, nice evening. Bye.
Bye.